Today we're going to look at graphing parabolas. There are two forms of quadratics, standard form and vertex form, and we'll explore graphing in each form. Take a minute to record this process. We're going to begin by looking at standard form. And in the first step, we are going to take a look at the vertex, which we've already done in the prior lessons, but you are going to have to apply the negative b over 2a formula to find the x value and plug it in to find the y value. Then you're going to create an xy table of 5 points. In your table, you'll have to put the vertex as the middle point, and you'll see that illustrated in a minute when we do an example. And you're going to have to pick two x's that are bigger than the vertex x value and two x's smaller than the vertex x value. You're going to substitute your values and find the y values that go with those other 4 points. You're going to plot your points and connect with a smooth curved line. You can also eyeball the axis of symmetry to see that the graph is symmetric on either side of the vertex. Here's our first example. The equation is x squared minus 4x plus 4. So to start off the process, we are going to find the x value for the vertex using the formula negative b over 2a. So in our equation, this is the b value here, and here the a value is 1. So when you substitute, you'll have a negative 4 over 2 times 1, which will become 4 over 2, and the xv is 2. Finding the y value at the vertex, we have to substitute 2 into the equation for x. So we've got 2 squared minus 4 times 2 plus 4, which will give us 4 minus 8 plus 4, which equals 0. So then we're now constructing an xy table here, and we're going to put in our x values. We start by placing our xv value, this 2, in the middle of the table, and we're going to center the other x values around it. So right now we know the xv and we know the yv, so that actually is placed in the middle of our table. And then we pick two values smaller than 2. So I'm going to go down by 1 and down by another unit, and then go up 1 unit, up another unit. And you always want to make sure when you pick your x values, they're spaced apart the same manner. So spaced apart 1 unit, 1 unit, 1 unit, 1 unit, and you're going down, down, up, up. Now we don't know the y values yet for these new x values, but we're going to take them and substitute them into the equation just like we did for yv. So that will generate 4 other y values, and then we'll be able to graph the parabola. So substituting 0 here into the x's, we'll find that we're going to get 4 for a y value. Substituting 1 for x, we're going to have 1 minus 4 plus 4 is a y value of 1. Substitute 3. 3 squared minus 4 times 3 plus 4 is 9 minus 12 plus 4, which is the same as saying 13 minus 12 is 1. And then 4 squared minus 4 times 4 plus 4 is going to give us a y value of 4. Now that we have our 5 points, you can go to a graph and plot them. Here's our 2, 0, x value, y value, 1, 1. So 1, 1 is here, 0, up 4. And then on the other side of the vertex, we've got 3, 1, so 3 up 1, and then 4 up 4. And then you want to connect with a smooth line through those points Okay, and of course this is just a sketch since we kind of don't have exact point for point when we get up there. Get in the habit, please, of putting arrows at the end of your parabola. Jumping right to the vertex form now. The process is a little different. It's in a way a little easier. Step number 1 is from the equation, get the vertex, which is your HK value, and immediately graph the point. Then in step 2, you're going to want to note that if the A value is positive, your parabola opens up, or if your A is negative, it's going to open down. And then in step 3, when you're putting the other points in the picture, you don't really need to make a table. We're just going to use what I call the step method. So let me explain this a little bit here. If you review these graphs, we have our parent function. These two graphs are the same here. It's just this one's a closer view. When you look at the parent function and you're starting at the vertex, when you go over 1 unit, notice the next point is up 1. When you go over another unit, the next point is up 3. When you go over another unit to the right, you're going to go up 5 points. And that pattern continues as you go over to the right 1 unit. You're going to go up 7, go over 1, go up 9, etc. So I call that the step method. And in this diagram here, it's just a closer look here at our 0, 0, 1, 1. So you can see the change in the y's. Goes up 1 unit, goes up 3 units, and then it would continue to keep going up with our odd number values. Now what you're going to want to take note is in the equation, if there is a number for the A value other than 1, you're going to want to multiply the A to each step number. So if your A is 2, then these numbers are going to change here for your steps. It's going to go over 1, up 2, over 1, up 6, over 1, up 10, over 1, up 14, and so on. Of course, at this point, I'm probably at a graph room. But the A affects your step. So your A has to get multiplied to these magic numbers here, the 1, 3, 5, 7. So here's the first example in vertex form. Notice here the A value is 1, so the steps are going to stay the same. We'll talk about that in a minute. And the K value is 0. So my vertex is at 1, 0 for this graph. So in the graph, I can actually find 1, 0 and immediately put a point. And then my steps are the same as the original. It's going to go up 1, up 3, up 5, etc. So from the vertex, I'm going to go over right 1, up 1, right 1, up 1, 2, 3, right 1, up 1, 2, 3, 4, 5. And then that's going to copy or be symmetric on the other side of the vertex. And you can count those individually again if you want, or just remember that it's got symmetry on both sides. And there's the graph for the vertex form. Here's a second example of graphing in vertex form. Here we have an A value and our H value and our K value, and notice the H is a negative in this case since it's a +1. So beginning with the vertex, we notice that the vertex is going to be at -1, 8, and we can plot that immediately on the graph. By the A value, since we have a negative, we know that the parabola is going to open downward. So it's from the vertex, it's going to be upside down here. And then for our steps, notice that the A value is 2. So it's going to multiply to our steps, 1, 3, 5, making them 2, 6, and 10. It is important when you're doing this for work that you show me the steps that you're going to use, whether they're changed or not, so that I know what you're thinking. So in our graph, from our vertex, we're going to go over we always go over 1 unit to the right and to the left, but I'm going to go to the right, 1 unit, This time my first point is 2 units away, or down in this case. Over 1, down 6. 1, 2, 3, 4, 5, 6. Over 1, down 10. It'll take us way to the bottom of the graph. So that's half of the parabola. The other half is going to be symmetric, so going to the left of the vertex, going to go down 2, left 1, down 6, left 1, down 10. And then you connect as best as you can. Notice this parabola is a little bit skinnier than the parent, and again that's all because the a value here, 2, is bigger than a 1 value. We'll notice when we talk about that, the negative is a totally separate issue. So it opens down and it's a skinnier parabola.